COVID-19 has been affecting us for over a year now. A group of scientists in beautiful Trondheim saw that in the summer the cruise ship traffic had to stop. And they were wondering, will this affect the sediment quality and the water quality? Let's go talk to them. Hello Marjorie, can you tell me more about this project?
In this project we are going to analyze zinc, copper and PAHs in the fjord because the PAHs originated from the fuel, while the zinc and copper from the paintings. Zinc is used as a stabilizer, while copper is used as a biocide. And we're going to compare this year's results with previous years to see if there was a real impact from the reduction of cruises.
So how did you go about getting these samples?
We went on an expedition in Gnerus where we took water samples from different depths, and we went straight to the lab to analyze the pH, conductivity, and we also took some sediment samples using a box cutter. And then we started the samples in a container, which we took to a lab and froze it to later analyze it through HPLC and ICP-MS.
We've now made our way up to Nunt, NTNU, where we are gonna speak with our scientists on the instrument used in this project. Hi.
Hey.
Good morning.
Good morning. So let's talk about ICP-MS, which means inductively coupled plasma mass spectroscopy. The method is suited for a large range of components. It permits the detection and the quantification of elements in total without any prior separation, if the ICP-MS is not coupled to a separation method. In this project, we are focused on copper and zinc contained into the water and sediment samples. The liquid samples are pumped into a nebulizer where the droplets are nebulized due to a flow of argon gas, and this is forming an aerosol. This argon gas passes through the ICP torch, producing a high temperature plasma and being accelerated. The nebulized sample becomes a gas. We say that it's getting decomposed or atomized when passing through the torch. It will then be ionized by the surrounding plasma. Next comes the MS part, mass spectroscopy. The ionized samples get through a vacuum chamber, permitting cooling and expansion. And then it goes into the analyzer chamber, which will allow to determine the qualitative and quantitative composition of the sample. It passes through the mass analyzer, and ions will be then dispersed based on their mass-to-charge ratio. The last step is the detector. The resulting ions induce a signal amplification transmitted to the computer for the processing of the data. The results are gathered in a mass spectrum of axis often being intensity versus m/z. We will use HPLC to measure the concentration of different PAHs. The concentration and identification of the PAHs are found by separating the compounds using a column. The column is packed with a stationary phase, which will separate any compounds entering the column according to their polarity. The samples will enter the column as a so-called mobile phase. A high pressure will force the mobile phase through the column, allowing for the separation. After the mobile phase has passed through the column, a detector will respond to the presence of the analytes. A chromatogram is formed with the time on the x-axis and the intensity on the y-axis. Peaks are shown in the chromatogram and the magnitude is determined by the amount of analytes in the sample. Working with HPLC, you distinguish between normal phase and reverse phase. The normal phase will have a polar stationary phase and a non-polar mobile phase, while the reverse phase chromatography will have a non-polar stationary phase and a polar mobile phase. We are using a reverse phase HPLC with acetronitrile as a mobile phase. To ensure the quality and correctness of the results, a standard solution is measured as well as blanks. The standard solution contains 16 PAHs and 5 fluorinated PAHs with known concentrations.
Now that we have a better understanding of how the samples were analyzed, we are heading back to talk to Marjorie about the results.
We have analyzed the concentrations of copper, zinc, and PAHs in marine sediment using a statistical test. We initially tested the data from Turishipskaya. None of our data was normally distributed, so we used Mann-Whitney U test on all of our data. Here we see concentrations of copper in the sediment at Turishipskaya. Our H0 hypothesis is that the sample concentrations from 2021 are equal to the concentrations of 2018, 17, and 16. We have 4 samples from 2021 and 8 samples from the previous years in total. We see that the mean from 2021 is close to 1/3 of the mean of the previous years. We chose an alpha value of 0.05. The p-value is 0.073. As the p-value is larger than the alpha value, the H0 hypothesis is accepted. This means we cannot statistically prove a difference between the concentrations of 2021 and the concentrations of the previous years. These are the results of the concentration of zinc in the marine sediment in Turishipskaya. Once again, the average concentration of 2021 is lower than the average concentration of the previous years. But the p-value is once again higher than the alpha value, so H0 is accepted. This means that the difference in the randomly selected value from 2021 and the set for the hysterical data is not big enough to be statistically significant. Here we see data of 7 different PAHs in Turishipskaya. We see that for all PAHs, the H0 hypothesis is accepted. Thus, no statistical differences in the concentrations are found. Due to small sample sizes, the validity of the test is small. We even see a p-value above 1 for CHR. We have made a histogram showing the means of the PAHs. The orange shows the average concentrations of 2021, while the yellow shows the average concentrations of 2018, 17, and 16. When analyzing the means, we see that the concentrations for 2021 are not always lower than the concentrations of the previous years. Due to low sample sizes, we decided to look into PAHs concentrations for Huveringen, as we have a larger dataset available from this location. We chose PHE and ANT as these PAHs have the lowest p-value and biggest difference in mean. Looking at this data, we see the means of the concentrations are close to each other, and once again the H0 is accepted. We also saw lower values for the means, which may indicate a lower cruise traffic by Huveringen. In conclusion, we were not able to prove any statistical difference in the concentration of neither copper, zinc, nor PAHs when comparing the data from 2021 to previous years. However, it is important to note that due to small sample sizes, the Mann-Whitney U test is unlikely to reject an incorrect H0 hypothesis. When looking at the averages for the historical data from the ICP-MS, it is seen that it's quite high, which may be because we have 2016 data, which was the last year with snow dumping in the fjord.
As we cannot get more data from the previous years, it will be difficult to improve the validity of the test. Since neither the histogram or the test showed a decrease in concentration, we can conclude that the lack of cruise ship traffic during COVID-19 didn't affect the concentration of trace metals or the PAHs.
So there you have it. The researcher could not find any significant decrease in the concentrations of the pollutants.